what do you think that function looks like? Y equaling e to the x, if we were to graph it. It's an increasing function, right? The base is 2 point something or another. It's bigger than 1, right? So what's one point that it would go through? 0, 1. They all go through 0, 1, including e to the x. What happens if I take e and I raise it to the 0th power? I get 1. Because when I take any number, except 0, and raise it to the 0th power, I get 1, right? Okay, what about when x equals 1? It's in between 2 and 3, right? So 2, 3, so they're maybe a little closer to 3 than 2, but okay. And the good news is when you go to -1, what's the reciprocal of e? It's a small number, isn't it? And you can do like kind of a fudge factor and you just go small. It's over there somewhere. If you want to be a little more accurate, then you know, you can go second ln and you want to raise it to the -1. Oh, what are you doing there? Did somebody hit graph? Pop one off. Second ln -1, that's its reciprocal, right? A little bit bigger than 1/3. 1/3 was 0.3333, so a little bit, you know, in that neighborhood. It looks like that. And again, if you forgot that, your graphing calculator didn't. If you go second ln e to the x, you know what I'm saying? Oh, deja vu. Right? If I trace, there's 0, 1, that's e, right? -1, that was that other number, and so on. Okay. Alright, now I want to spend just a few minutes talking about this last thing in 4.2. And it's going to be this idea of solving exponential equations. And truthfully, I don't like what we're about to do very much. Okay? It's going to be tricky unless you have mad exponent skills. Okay? And in fact, I'm willing to go out there and say most of you don't have mad exponent skills. Is that fair? Like if I said, what's 3 to the 5th power? Does anyone know? Or 4 to the -2 power? Does anyone know? If you had a calculator and you thought about it, you could, you know. But you'd have to already know that information, really, to be able to work a lot of these problems. And that's, you know, that's going to be complicated if you don't have those skills. So, at the end of this chapter in section 4.5, we're going to sort of talk about solving all kinds of equations, exponential equations, logarithmic equations, and I'm going to give you a method that works for any exponential equation, but I don't have the tools yet to show you that, okay? So the last thing that we're going to do is solving exponential equations in this section. And it's going to go like this. I don't want to just make up numbers. So let's say we have 9 to the 4x minus 1. And I want to find the value of x so that, well, I can only move it temporarily. I'm going to put this back up in a second. When I say solve this equation, though, that means find the value of x so that the left-hand side of this equation has the same value as the right-hand side of this, right? Any ideas? Any guesses? Just ballpark it. What do you think the value of x would be? I want to see how close you can get. No guesses? That's fine.
I mean...
You think it would work for auto numbers? You think if I plugged in 1 million here and 1 million here?
No.
Probably not. But what about 999,999? No, probably not. Okay? So how do you get this number? This is going to be really tricky because when our variable's in the exponent, we don't have very many good ways of really manipulating that exponent. Okay? So the trick to these kind of problems for right now is get a common base. If you can manipulate those a little bit so that you get a common base, then we can work with that. Okay? So I'm going to look at my two bases, 9 and 3. And I'm going to ask you, is there some nice, clean, exponential way in which 9 and 3 are related?
3.
What about 3?
Well, if you...
Tricia, say it. What's squared?
3 squared.
9 is the same thing as 3 squared, isn't it? Okay, so what I'm going to do is I'm going to rewrite this side as 3 squared raised to the 4x minus 1 equals 3 to the x plus 8. What if you didn't know that? Then you're screwed. It's the problem with this method. Seriously, okay? So because I was able to rewrite 9 as 3 squared, I then have some other exponent rules that say if I have something with an exponent raised to an exponent, I can multiply those exponents together, right? So if I multiply this 2 times that exponent, I'm getting 3 to the 8x minus 2. And that still equals 3 to the x plus 8. And this is the trick to the problem. Because I was able to get a common base of 3. Right there, do you believe that that says base equals base? They have the same base? If this base equals this base, if this base equals this base, the only way those two guys are going to equal each other is if their exponents equal each other. Okay? So if 3 to the something equals 3 to the something, then the something here has to equal to something there. Reasonable? If I told you 3 squared equals something, 3 to some power, it can only be 3 squared again, right? 3 squared doesn't equal 3 to the third or anything like that. So what I'm going to do is I'm going to take this exponent, 8x minus 2, and I'm going to set it equal to that exponent, x plus 8. Okay? So once I get it to base equals base, then the next step is exponent equals exponent, right there. And then it's a much easier problem. Just solve for x, right? It's a linear problem. And I'm going to let you do that. Are y'all getting a fraction? (10/7). And you can admit it, that was the number you were thinking at the start of the problem. It just didn't seem right, so you didn't want to say it, right? 10/7.